Solving linear systems is an important skill to have as an engineer, and in case you need extra incentive, I've picked a former midterm question as the example for this pencast. Okay, let's start off. Let's rewrite the system. So you've got it in front of you. And the final equation is here. And remember, part A was write the system in an augmented matrix. Okay, this is an easy mark. The only tricky thing could have been if the variables were not lined up in the right columns, but you can see that they are. And so all you do is transpose all of the coefficients into the numbers. 1, 2, 1, right-hand side minus 1. Then I've got 2, 2 minus 3 is minus 18. And I've got 1, minus 1, 1, 5. So there's our augmented matrix. And part B was do row operations to change the augmented matrix to row echelon form. And remember, we're going to write down a sequence of augmented matrices. They're not going to be equal, but they're going to represent linear systems that have the same solutions as this one. Part C of this question guarantees that there is going to be a unique solution. So the solution that comes from the augmented matrices that we write is going to be the same as the one that we want to this original system. So I'm going to do row operations. Well, what row operations am I going to do? The first row operations I have to do are to eliminate these entries up here. And so to eliminate this entry, I'm going to take, well, first of all, I'm going to leave row 1 alone. To eliminate this entry here, I'm going to take row 2 minus 2 row 1. Remember, that doesn't change the solution of the linear system. So here I get 2 minus 2 is 0. That's why I took this multiple. Here I get 2 minus 2 times 2, that's minus 2. And here I get minus 3 minus 2, that's minus 5. Of course, I have to do the same thing to the right-hand side here. I get minus 18 minus minus 2, that's minus 16. Okay, now I'm going to go on to this entry, which I have to eliminate, and I'm going to do that by taking row 3 minus row 1. Again, coefficient of 1 here is because that's what's going to give me my 1 minus 1 is 0. Right? This makes me happy to get these zeros over here. It makes the system simpler. Here I'm going to have minus 1 minus 2, that's minus 3. And here I'm going to have 1 minus 1, that's 0. And finally, in the last row, I'm going to have 5 minus minus 1, that's 6. Now, except for the phrasing of the B question, if we were a little bit tricky, we could find the solution right now by looking at this last equation, which is going to tell us that minus 3 times y is 6 So we could have started here and done some slightly different back substitution to get the solution, but we're kind of constrained by the phrasing of the B question that we have to go on, and we have to eliminate this entry. So I'm going to do another augmented matrix where I leave the first row alone, I leave the second row alone, and this third row now, the circle of doom is on this entry, and this is just a little bit more complicated arithmetic, but now I'm going to take row 3 and I'm going to subtract 3 halves times row 1 times row 2, sorry. So that's going to give me 0. That's going to give me minus 3 plus 3. That's the 0 that I want. Now I'm going to have 0 minus 3 halves times minus 5, so that's 15 halves. And here I'm going to have 6 plus 3 halves times plus 3 halves times 16, so that's going to be 6 plus 24, that's 30. And now we finished part B. We have the matrix in the augmented matrix in row echelon form. And now we can go on to part C, which is find the solution. The question guarantees that the solution is unique, so that's quite nice. You can see from the structure that yes, there will be a unique solution. And we're going to do back substitution. We're going to start from this last equation, which says that 15 halves times z, remember these are the coefficients of z in that column, is 30. And that was the point of doing the Gaussian elimination, is we get a simple equation for at least one of the unknowns, and that tells us that z is 4. Then we can go back up. That's why this is called back substitution. We can go back up to this equation, which tells us that minus 2 times y minus 5 times z is minus 16. But we already worked out what z was, so this tells me that minus 2 times y minus 20 is minus 16. That tells me that minus 2y is 4. That tells me that y is minus 2. And then finally, we can go up to this one. This equation here tells us that x plus 2y plus z is minus 1. Now that wasn't particularly helpful unless you realize we've already worked out what y is and what z is, so this is going to be an equation for x. So that tells me that x minus 4 plus 4 is equal to minus 1. That tells me that x is minus 1. Okay, so let's write out the solution here. A nice little box. Final solution is x is minus 1, y is minus 2, and z is 4. Finished. Perfect marks on this very typical midterm question.